Quick addition to the rambling long video. Maybe we'll try to inject this part into where it fits. I talked about the idea that quantum fields, or the quantum entity, came first before anything else, was the first thing to appear to start the step-by-step process of producing our universe. And I forgot to mention the evidence that we have for that. And the evidence, I sort of mentioned that quantum entities do not respect, do not really deal with space and time, particularly space. And there's a lot of evidence for that. First of all, when you have a quantum field, before you observe a particle or before you observe anything, it's not sort of fully real. So we're kind of still crossing that boundary between the ineffable vacuum and the physical world that we see around us. Second, quantum entities have this thing called entanglement, which Einstein called spooky action at a distance. Two particles can be light years apart and still have the exact pure perfect connection, such that if you do decide to observe one, you immediately know without any time delay whatsoever that the other particle has its compatible property. Like if you're observing a spin and you observe spin up for an electron, and it's entangled with this other electron, the other one will have spin down. And it takes zero time for that manifestation to happen, although you can't exchange information by doing that. And that's essentially there's a law, a theory that John Stuart Bell invented or discovered in the 1960s, at a time when people were poo-pooing studying quantum foundations and the underlying philosophy or reasoning behind it. They were just using it. Physicists like to just do their work, shut up and calculate, and not worry about what it all means in some philosophical sense. But Bell proved that this spooky action at a distance produces a different effect than if that doesn't exist. And if there's some like secret hidden variables or whatever it might be that explain that spooky action at a distance. So bottom line being, these two particles completely disrespect space. They are just going about in their own realm, connected, and essentially no space between them. Finally, then, it's just the basic third idea that when you don't observe a quantum entity before you observe an excitation that can be defined as a particle, its field is spread throughout all of space. Every single square inch of the entire universe has some finite probability that that particle is there. And popular crazy people use that idea to say, well, all of a sudden I could pop up in Cleveland, just quantum tunnel from here to Cleveland. Well, that's the idea, but of course a macroscopic object like me, made up of gazillions of particles, they all have to do the same thing at the same time, and chances of that are so prohibitively small that it's absurd. But for an individual particle, it exists in the quantum realm everywhere in the universe, completely disrespecting space. So that's the evidence why quantum fields came first and space came along to try to complicate the situation, but get it a little bit closer to what we see as our observed universe. All right, that turned out to be a lot longer. As always, I ramble. Talk to you again soon. Take care. Bye-bye.